Fun part of this video, which is putting it all together. I've not had time to spray paint everything. It would be nice to paint everything, but unfortunately the temperature outside is 2 degrees with a wind chill of about 15 below zero. I think my hand is going to freeze before the paint will come out of the spray can. So let's take a look at how this whole thing goes together. So we have the rocket now, and you'll see there is no swivel on here. There's really not much space. The rocket mounting here and the nose cone shoulder here, this is with about 2 inches of space, so we do not have a lot of space to work with. So there's no swivel on this one. And you can see I put on this end the traditional loop for attaching things that I've done before. So this is the standard Kevlar recovery system that I've been building for the last several weeks. And the recovery system is a standard Kevlar blanket with a standard streamer. I like to say standard because this is the way I like to build things so that the parts are all interchangeable. And this particular streamer is the same as that so-called spotting streamer that I built in a previous video. This streamer, believe it or not, is 40 feet long. So what's interesting is that I did the center winding on this. So the center of the streamer is the center of the actual winding itself. And the two ends meet up here. So when this opens up, it snaps open like a party popper. What's really interesting is that people have commented, it's like, well, wait a minute, the Kevlar doesn't stretch. How do you absorb the shock? The idea is I don't want to absorb the shock. When the ejection charge goes off, it's going to throw this Kevlar cord out, and it's really stiff. It doesn't stretch at all. But when it hits its maximum length, it's going to snap the end. Well, what's at the end? Well, we got the streamer inside of the blanket. So it's like snapping a towel. The end of it's going to pop, and it's going to transfer all that energy to the streamer, and the streamer is going to go flying out. So that's why we don't want to waste that ejection energy. We want to use that ejection energy to open our streamer for us. Okay, so I'm just going to put this together like I have done for plenty of other videos. And again, it'd be nice if I could paint this, but I don't have it painted. So we start out by taking our loop and I put it through a blanket. Put it through the nose cone. And I'm going to pull the knot through there. And pull through here as well. Okay. A little tight doing that. This knot with the Kevlar on it is like a rock. It's extremely hard. So got to make sure that that knot is very, very tight so it's going to pull through. There is a slightly larger eyelet that I can use here, washer. However, the problem here is so far in the nose cone, that's pretty tight. Okay, so I'm just going to take the loop and put the nose cone and the Kevlar blanket through it, like I've done plenty of times before. And I'm just going to pull the knot back through the nose cone. And pull it back through the blanket. And then back through the knot. And now we have our blanket attached. See, we transferred the knot onto the cord. So now the nose cone and the blanket are attached, and it's attached to the cord here. Now this will, of course, slide a bit, so this is not certainly what we want to have. We want to have this tight up to the top so that this stays very, very close to the nose cone. So now we just put a knot in this, and again, it's real easy. You just take this, flip it to make a little simple overhand loop, and now I put the nose cone through the loop from the top, and then I just pull this tight around here. The real trick is trying to pull that big knot around. It's not so easy to pull it around, but let's go ahead and keep on working the knot here. Okay, there we go. So now the knot has come through, and now it's much tighter. I could probably tighten this up a little bit more just by pulling on it. And if you're concerned about it coming apart, you can put another knot in there. This is not that much of an issue. It's a very light nose cone and not a very light blanket. and not a very long cord, so this shouldn't be too much of a problem. Okay, so let's go ahead and mount the streamer. We do the same thing with the streamer, and this is why I like putting things together with knots and Kevlar, is that everything just ties together. We don't need clips, we don't need metal. We just pop it together with a couple of knots. And again, the feature of this particular design is that everything has a flight stress on this particular metal washer right here. So this cord is tied to the washer, the streamer is tied to the washer, everything is tied to the washer. And that puts all the stress on the washer. I have had other flights where I put everything on the nose cone and it tore the eyelet off the nose cone. After seeing 2 flights with the nose cones tore off, I said, well, okay, I need a better solution. And that's why now I do it this way. Okay, so there we go. We're all set for flight. So let's go ahead and just kind of give an example of wrapping this whole thing up. So you see again, we got the blanket, we got the nose cone and the streamer. So let's assume that there's some wadding inside of this. And again, once you've got that engine mount in here and you've got the nose cone on here, there's about 2 inches of space, not a lot. So let's go ahead and put this all together. And we don't have a swivel here, so we'll just start winding. This is the winding technique I've shown on other videos where it's basically a figure 8. The figure 8 will twist forward, then twist backwards, which will twist and untwist it so it does not put any twist or knots into the cord. You pull it off, you get this little wad like this, and just stuff it in there. And that stuffs in very, very easily. Then we want to stuff our streamer in there. This is about the longest streamer that I can fly with the BT-50. If we look at the other streamers, what made out of the other bird tape, which is 1 inch, the maximum for BT-50 is about 25 feet. For this particular tape, it's only a 1/2 inch, but it's also a little bit thinner. Okay, so all we're going to do is just put this on top of the blanket, fold the blanket over, and then what we want to do is to hold this and stuff it into the rocket body. That's real easy to do. Well, Kevlar's kind of like trying to push a rubber band. Okay, so this goes inside here, and just push the blanket in, and just like that. Goes in fairly easily. And if you think about this, this is one of the reasons why we don't want to have a shock cord, an elastic shock cord with an anchor, because you put that in there and it's going to really be a very, very rough surface, and it's going to make it difficult for this streamer to eject. I also want to again comment that this rocket, the reason I selected this rocket was that it does have an engine hook. It takes more pressure to blow this streamer out than it does just to blow that little 1 foot streamer out. So the regular streamer this comes with is about like this. I think it's maybe a little bit longer, 1 to 2 feet. That's easy to blow out the end. However, to blow a 40-foot streamer out, you need a lot of pressure. So you want to keep that engine in here. Otherwise, that pressure may blow the engine out if you're using a friction fit. So I'm just providing the warning to avoid doing a friction fit if you're running these large streamers, because they may pop your engine out. I don't like using friction fits. I usually will go back and just simply add an engine hook anyways. Okay, so there we go. I just wound up the top piece and I put this on, and we're ready for flight. There would be some wadding in here, and when the weather gets better, I'm going to certainly paint this. So here we go. This is my Mini-Max with I'm going to say a maximum streamer. Actually, the nose cone keeps popping off. It's fairly loose. A little bit of tape will fix that. So yeah, so this is really nice. It's going to be a nice rocket, a nice flight. The biggest engine I can put into it are these T-size engines, as they're called. They end in a T. People say that's for tiny. I'm not really sure what they were used for, where that annotation came from. This is a quarter A that I used on a different rocket, but I usually put the full A engine in here. This rocket will be a slight bit heavier than the rocket if it had only this small streamer in it. So I'm going to fly this with an A10. The higher thrust will get this off the pad a lot faster and give us a nice high flight out of it. And I can hardly wait to videotape this rocket going up and popping out a 40-foot streamer at maybe 300 feet or maybe more. So this is it for the Mini-Max. I'm thinking about building a few more of these. I really like this rocket. So this will be a red Max. Maybe I'll make a white Max. Maybe a yellow Max. Whatever. Oh, by the way, this the glue has dried on the launch lug. It's been sitting around here for a couple of hours now. And you can see the glue, the E6000, is basically pulled up to make a nice smooth fillet. And on this side as well, nice smooth fillet. Now notice I didn't do anything more than just stick the glue down, or stick the lug down with all the glue on it. And it turns out that this glue, once it dries, it contracts a bit. And if you want, you can always smooth it up by putting some rubbing alcohol on your finger. But this is really nice. It's a very nice rocket, and I'm getting excited to see this fly. Coming up in about a week is another attempt at our polar bear launch through the NIRA Club, the NIRA, the Northern Illinois Rockets Association. We were going to fly this last weekend, but when we saw the temperature was going to be only about 8 degrees, I figured our hands are going to freeze before we get the igniters wired. Hopefully next week is going to be a really nice day. It should be hopefully in the lower 30s, which for me is good enough day to launch. I'm going to bring all my new rockets. As you notice from my rockets videos, I have about 10, actually 12 new rockets, including this one that I just want to go on the launch pad and let it fly. So anyways, so that's the story of my mini Max, my mini Red Max. I've used this to demonstrate some very important techniques for putting on the launch lug, putting on the fins, putting in the engine mount, building the streamer. And it basically uses some of the very sophisticated techniques used in much larger rockets. But these techniques, when you use them on the smaller rockets, make this rocket will last indefinitely. I can put this through 100 flights and I won't have a single problem with it. So this ought to be a very, very nice rocket to launch. I really like how this glue dries, that Tight Bond 3 glue. It is incredibly tough, and I've never yet had a fin break off. One thing I'm going to do is that when I paint this, it recommends a white primer, but for the nose cone I'm going to use a gray primer and then put a black gloss on it. I have both gray primer and black gloss. The gray primer is actually special. That's automotive primer. It's used for a sanding filler primer. It's pretty amazing stuff. You spray it on, and for some reason it'll smooth over all of your imperfections. So it's really interesting stuff. So I'm going to spray this with the body and the nose with a gray primer. The nose will be followed with a black gloss. The body will be followed by a white flat primer. And once I have that done, this ought to have a nice, very, very smooth white surface. In that case, I'll give it the coat of the red paint. And the white primer under the red paint will give it a slightly brighter color. If you put a gray primer underneath a paint, it's going to give it a deeper color. So this is what I want to do. I want the Red Max to look nice and bright. So it's going to have a white primer under this. Okay, so that's it for this series of videos. Enjoy, and I hope everybody's going to now build this Mini Max and look at this. Say, that's a very sophisticated rocket. Look what I can do with it. So have fun.